we're on lesson 5.1.4, and this is on trigonometric applications. So now keep in mind, you already have the tools of SOHCAHTOA. We're going to read through all these different realistic situations, word problems, yes, and then figure out which one of the trig ratios are we going to use so that we can figure out what is the missing information here. Okay, so before we start, I would strongly recommend that on top of your paper, just kind of remind yourself of SOHCAHTOA, right? So SOHCAHTOA, so that way you can figure out which one you need to use. Okay, all right, let's see the problem here. David and Emily are climbing El Capitan, a big cliff wall in Yosemite National Park. So I've heard this is a really flat side. David is on the ground holding a rope attached to a carabiner, a rope pulley above Emily as she climbs. When Emily stops to rest, David wonders how high she has climbed. The rope is attached to his waist, about 3 feet off the ground, and he has let out 48 feet of rope, which goes up to a carabiner and then back down to the wall to Emily's harness. The rope at David's waist makes a 55-degree angle with the ground, and he is standing 20 feet away from the base of the wall. Assuming the rope is taut, pulled tight, so there's no lag in it, right? It's not like sagging. Approximately how long is the rope between David and the carabiner above Emily? All right, so let's see. We are looking at, okay, all right. So let's look at the picture here. This is David, all right? Now remember, David is standing about 3 feet, well, he's not standing. Well, his waist is about 3 feet off the ground. So this is our beautiful graph, okay? And this is the El Capitan part of it. So El Capitan. Okay, so kind of our picture here, right? Okay, so he is giving a rope, going this way, and then he is, piece of information we know is he makes about 55 degrees with the ground, and he's standing 20 feet away from the base of the wall. So he is standing 20 feet away from the base of the wall, right? So assuming the rope is taut, approximately how long is the rope between David and the carabiner above Emily? So this is not where Emily is. This is a carabiner, is the hook into the rock. Emily is actually here somewhere, right? Okay, it looks really bad. So it should be right around her waist. Sorry, it's not hung on her head. So this is where it's not going to be right at Emily. It's going to be a little bit above her. Okay. All right. So we're looking for this X here. Okay. All right. So let's see. Based on this picture, what do I know? I know that the wall and the floor makes roughly a 90-degree angle, right? And I know then that since that's a 90-degree angle, this must be my hypotenuse. And this 20 feet here is touching my angle, so that's my adjacent, right? Oops, I am writing wrong words. Adjacent. Okay, adjacent and hypotenuse. Go back up to look at my SOHCAHTOA. Adjacent hypotenuse, A and H. So I'm using cosine here, okay? All right, so now I'm going to set this up and say, okay, cosine of 55 equals adjacent over hypotenuse. Okay, now again, because we're not solving for a missing angle, we're solving for a side, we're using just cosine. And go ahead and swap the values because x, the variable that we're looking for, is in the denominator. So you have x equals 20 over cosine of 55. All right, so you have 20 divided by cosine of 55. That gives me the hypotenuse of 34.869 feet. All right, so how long is the rope? The rope is 34.869 feet. So it says, how long is the rope? The rope, don't forget to answer the question. That's why I'm looking back at the problem again. The rope is about 34.869 feet long. Okay, all right. Now, how high up the wall has Emily climbed? Describe your method. Now, remember what they said. She is, we don't know how high up she is, but we know that the rope he has let out 48 feet of rope, right? It says right here, he has let out 48 feet of rope. Now, this rope that we calculated, the rope over here on the hypotenuse is only 34.869. So the remainder of the 48 feet must be right here hanging on to Emily, right? So we need to know two things. We know a lot of things. We want to know how high up Emily is. We want to know this length right here, right? But we also, we know from the 48 feet of rope, we know how long this length is right here. Okay, but our trig ratio allows us to figure out this whole thing. Okay, so that's a lot of different pieces here. So let's do that missing piece right there first. Okay, so this is my, based on this picture, this is my opposite. Okay, and I have adjacent. I have the value for adjacent. So opposite and adjacent, I can use tangent. So let's use tangent here. So I'm going to say tangent of 55 degrees equals opposite over adjacent. Adjacent is 20. So if you multiply 20 over, 20 times tangent of 55 will give me the opposite side. 20 times tangent of 55 degrees. So the wall, or at least the full length of the height, the full length of El Capitan from that 3 feet length all the way up to where the carabiner is 28.563 feet. Okay. All right. So pause on that. Because we let out 48 feet length of rope, so I take 48 minus 34.869. So 48 minus 34.869. The rope above Emily is 13.131 feet. So now I know, based on this picture, I know this length. I know this length. I now can answer to you how high up El Capitan is Emily, right? So let's see. I take the full length, the full opposite side, and I subtract how much rope is above Emily to get you 28.563 minus 13.131 to get you the fact that Emily is 15.432 feet up El Capitan. But don't forget, this whole thing is measured 3 feet above David's waist. So you got to figure out this length right here too. So 15.432, you need to add 3 feet of David's waist to get the fact that Emily is really 18.432 feet up El Capitan. So how high up a wall has Emily climbed? Emily has climbed, doesn't sound like much, but I don't know about mountain climbing, so maybe this is a lot, about 18.432 feet. Okay, again, so if you didn't catch that, rewind and go back and watch how I use the different parts of my problem to figure out this little piece that I want, which is her height up El Capitan. Okay, all right, next problem. The Bungling Brothers Circus is in town, and you're part of the crew that's setting up the enormous tent. The center pole that holds up the tent is 70 feet tall. To keep it upright, a support cable needs to be attached to the top of the cable, the top of the pole, so the cable forms a 60-degree angle with the ground. How long is the cable? So again, pictures very, very helpful, right? So here's your ground, and here's your center pole. Okay. Hold on. All right. So the pole is 70 feet tall. Right, the pole is up 70 feet tall. And then we need cable to attach the top of the pole and then hold it to the floor here, right? So if the cable needs to form 60-degree angle with the ground, right? So it's cable to the ground. So how long is the cable? We want to know this. This is our X, right? So you always need to make sure you have your variables labeled and all your information labeled in the correct place. Okay, now let's use SOHCAHTOA to figure this out. First of all, the pole and the ground must make 90 degrees. So that means this is my hypotenuse. Okay, and then based on 60 degree, that side over there, the 70 feet, because it's not touching my angle, it's my opposite. So O and H, that's SOH, sine. So that means I have sine of 60 degrees equals opposite over hypotenuse. Again, because we're not solving for a missing angle, we're not going to use inverse. And because our variable is on the bottom, we're going to swap the denominator with sine 60. So x equals 70 over sine of 60. So 70 divided by sine of 60, you get 80.829. So that cable must be about 80.829 feet long. Okay, so about, you always say about because it's not exact. You had to round and you had to chop off some of those decimals. Okay. Okay. How far from the pole should the cable be attached to the ground? So how far from the pole? So what is this problem asking? Part B is asking how far from the pole must the cable be attached to the ground? So right here, that's what this problem is asking. So since I already used the variable X, I'm going to use W just because, all right? So, okay, so now you don't want to use X. You don't want to use the hypotenuse you just solved, right? You don't want to use that number because that's something you solve for. And again, the domino effect, if you use something you solve for to solve for the next thing, you might mess up. So let's look at what I have. I have the angle 60 degrees. I still have the opposite side, but now this W is my adjacent. So I have opposite and adjacent, I have tangent. So I must use tangent of 60 equals opposite over my adjacent side, okay? Again, you have your variable on the bottom, so swap it out. W equals 70 over tangent of 60. So you get 70 divided by tangent of 60. So that's about 40.415 feet. So that's how far away from the pole that the cable should be attached. So about 40.415 feet away. Okay, all right. All right, well, El Capitan again. Nathan is standing in the meadow exactly 185 feet away from the base of El Capitan. At 11 a.m., he observes Emily climbing up the wall and determined that his angle of sight up to Emily is about 10 degrees. If Nathan's eyes are about 6 feet above the ground, oh, Nathan's tall, about how high is Emily at 11 o'clock? Okay, so, sorry, I'm laughing at this picture because I remember in the past year, my students, they did not like this picture too much. So it's not a very good depiction of what's happening here. So maybe we can draw a better idea of this. So here is not the floor, but this is Nathan's eyesight, right? So Nathan is looking up and he sees Emily up there. And this is El Capitan. So this is Emily right here. Well, assuming he's looking at her head. All right. So his line of sight is 10 degrees. His eyesight is 6 feet, right? And he is standing 185 feet away. Okay. All right. So how high up is Emily? This is what you're looking for. That's your X. So again, now look at what we know. We know El Capitan, the floor is 90 degrees. So then this must be my hypotenuse. I got nothing there. That's okay. The 10 degrees is my angle. So this 185 is my adjacent. And this is my opposite. So I have adjacent and opposite. I need to use tangent. So tangent of 10 degrees equals opposite over adjacent. Multiply 185 over. So 185 times tangent of 10 degrees. That gives me about 32.62 feet. Now remember, that is the length from Emily to right around here. Then you gotta add up his height, his eyesight height, right? So 32.62 plus 6 feet, so 38.62 feet. So about how high is Emily at 11 a.m.? So she's about 38.62 feet up El Capitan at 11 a.m. Okay, now at 11:30, Emily has climbed some more, and Nathan's angle of sight to her is now 25 degrees. So see, it makes sense. At first she's a little bit lower, so it's 10 degrees. Now his line of sight is a little bit higher because she's climbed up more, right? So his angle's changed to 25 degrees. How far has Emily climbed in the past 30 minutes? Wow, in 30 minutes, the angle went from 10 degrees to 25. It's quite a bit. So let's see. We can figure out the same thing as before. The picture's going to change just a tiny bit, right? So we're going to say, all right, he is now looking at her this way. This is 25 degrees. He's still standing 185 feet away. We just don't know this one right here. That's That's our x, right? She has a new height, right? So it's still based on what we have here. We still have our 90 degrees here. I have my hypotenuse here, which I don't have any values, but then based on the 25 degrees, I have my adjacent and hypotenuse, so I'm still using tangent. So tangent of 25 degrees equals opposite over adjacent, okay? So same as before, I'm going to multiply 185 over times tangent of 25 equals our x. So 185 tangent of 25 degrees this time. So x equals 86.267 feet. Okay, now you don't have to add his eye height in this case because all we're looking for is the difference between what he had seen at 11 a.m. versus what he sees now 11:30. So you're looking for the difference between those two numbers. So you don't need to add his height, his eyesight height in. All right, so let's compare the difference between those two numbers. We're comparing the difference between the two heights that she has climbed. So what he saw at 11 a.m. versus what he saw at 11:30, right? So we're going to compare the difference and we're going to say 86.267 minus 32.62. So 86.267 minus 32.62. So she's climbed 53.647 feet in 30 minutes. That's really, really impressive. That's a lot of height to cover. Okay. Now, if Emily climbs 32 feet higher in 10 more minutes, at what angle will Nathan have to look in order to see Emily? All right. Again, because he's still at the same eyesight height. So you can actually ignore the eyesight when you're talking about just the changes in her height up El Capitan. All right. So she climbed 32 feet higher. So let's see, this is what the changes in our picture is going to look like. So he is now at a much different angle than we had before. We don't know what that is, but she is 32 feet higher. So 32 feet plus 86 that she was at before. So 32 plus 86.267. She is now the height at 118.267, right? That's how high up she is. He is still 185 feet away. This now is the angle we don't know, right? So now let's look at this picture and say, all right, I got my 90-degree angle. I have my adjacent and opposite. So I'm still using tangent, but we're solving for angle this time. So we have to use the inverse function. So setting up is tangent of the angle equals opposite over adjacent. And now to solve for the angle, I need to use inverse. So tangent inverse of 118.267 over 185. So tangent inverse of 118.267 divided by 185. We get the angle of 32.59 degrees. All right. So what angle is he looking at? He's now looking at her at an angle 32.59 degrees. So a lot more, right? He started at 10 degrees and he had 25 degrees, now 32 degrees. So 3 times more than what he was looking at before. Okay. All right. Last problem here. Forrest needs to repaint the right side of his house because sunlight and rain have caused the paint to peel. Each can of paint states that it will cover 150 square feet. Help Forrest decide how many cans of paint he should buy. So we got to figure out how much area he needs to paint, right? So find the area that would be painted. So let's make it easier first, right? You know that what you have here is really a trapezoid, but you could actually cut this up and say, okay, I have a rectangle and a triangle, right? So let's look at the triangle itself first. Well, if I look at that triangle, I can see that this is 90 degrees. This angle here got cut off. Well, if this is a rectangle here, you need to cut off 90 degrees. So 126 minus 90 gives me 36 degrees. So this angle here is 36 degrees. I got 9 meters up there. Okay. I need 2 things. Actually, I need all the information I can get, right? So I need, let's see, this is a hypotenuse, this is my opposite, and this is my adjacent. I need both of those values. So we're going to take it one at a time. You cannot solve for both opposite and adjacent because you have nothing there. So cover up the opposite for now. So cover up the opposite for now and look at the fact that I have adjacent and hypotenuse. Well, adjacent and hypotenuse, that's cosine. So cosine of 36 degrees equals adjacent over hypotenuse. So 9 times cosine 36 degrees equals adjacent. So 9 times cosine 36 degrees, that gives me adjacent to be about 7.281. Now, let's cover up the adjacent and solve for the opposite. All right, so now I have opposite and hypotenuse, that's sine. So sine of 36 degrees equals opposite over, and if it helps, put opposite because O looks too much like 0. Opposite over hypotenuse. So 9 times sine of 36 equals opposite. So 9 times sine of 36 degrees gives me an opposite to be about 5.29 feet or meters. These are all meters. Okay. All right. I think I have enough information here. Okay. So let's fill in what I know. I know this side is 7.281. I know this side is 5.29. This is still 8. This is 7.281. Okay, so now I can actually solve for this triangle here. Area of the rectangle is base times height, so 8 times 7.281. So 8 times 7.281. That gives me the area of 58.248 square meters for the rectangle. For the triangle, I have 1/2. The base and the height is what makes 90 degrees, so base and height, both of these. So 1/2 of 5.29 times 7.281. So 1/2 times 5.29 times 7.281. That gives me 19.258 square meters. Okay, so let's add them up. A total area, so 58.248 plus 19.258. So 58.248 plus 19.258. That gives me a total of 77.506 square meters. That's the total area. Okay. Assuming Forrest can only buy whole cans of paint, how many cans of paint should he buy? So first of all, we got to change these to square feet because this is square meters, right? So 1 square meter equals 10.764 square feet. So I go 77.506 times 10.764. That will give me 10.764. That will give me 834.275 square feet. And then each can only paints 150. So I take 834.275 and divide it by 150 because that's how much paint, how much square footage will be covered by each can. So divided by 150, I get 5.56. You can't buy half a paint, so you've got to buy more, right? So you cannot buy 5 cans, you got to buy 6 cans. So he needs 6 cans of paint. Okay. All right. Please spend some time reading through this methods and meanings. It kind of just reinforces the ideas of inverse trig functions and really when to use them and how to use them, right? This will really, really help you prepare for the upcoming quiz that will cover 5.1.1 all the way through 5.1.4. Okay, that's it, guys.